number 11 on page 317 of your Math 3000 textbook. It's asking to find the angle formed between two lines, and I've written them out over here. Line 1 is represented by the function y equals 3/2 of x plus 1, and line 2 is y equals negative 3 over 2x minus 1. So if I were to quickly sketch this in orange, I would have line 1 looks something just a little bit like this over here. So it's positive and it passes through point number 1 on the y-axis. And line 2 is negative going through negative 1. So something like this. Approximately. This is just a sketch. So I would have line 1 here and line 2 here. Now the question is, what is this angle here formed between the two lines? Now, the way I'm going to go about this is find this point of intersection. And then I'm going to find another point on the line here, another point on the other line here, form vectors, find the components of these vectors. So let's show the components in yellow. So here's 1, and here's the other. I'm going to find these components, and then with these components, with these two vectors, I will use the scalar product to find theta, the angle between them. So let's start by finding this point of intersection. Now, I do this by the comparison method. I have this equation and that equation. They're both equations are equal to each other at this point over here. So I have 3 over 2x plus 1 equals minus 3 over 2x minus 1. Now if I bring the x to the other side, I have 6 over 2x equals, and I bring them 1 to the other side here, I get negative 2. Now after cross multiplying, I get x equals negative 4 over 6, and that's just negative 2/3. And I plug this back into any of these equations up here to solve for y. So y is equal to 3/2 times negative 2 over 3 plus 1. Now, this cancels out and gives me 1. So, because it gives me negative 1. And negative 1 plus 1 is 0. So the point of intersection is at negative 2/3, 0. So this here is actually on the y-axis, and that's, sorry, on the x-axis, and that's negative 2/3, comma 0. This is the point over here. Now let's find another point on line L1. Let's choose x at 2 here. And I do that because I notice that I'm dividing by 2, so choosing a multiple of 2 will make it easier for me to apply this formula. And when I replace x by 2 in line 1, I get 3 over 2 times 2 is 3 plus 1, and so this height here is at 4. So this is 0.24. And if I do the same down here on the line 2, also choosing x equals 2, I get negative 1 minus 1, that's minus, oops, that's not 4, that's 2. Oh, no, that is 4. And that would be minus 4 here. So I have 2 minus 4 here. Now I can make these my vectors, and let's find the components of these vectors here. The x component here is 2 minus 2/3. So that's 2 minus 2/3 is plus 2/3. And that gives me, so that's like saying 6 over 3. And that's 8 over 3. So my x component is 8 over 3. My y component is 4 minus 0 is 4. So I've got 4 in height here and 8 over 3 as a horizontal distance here. Similarly over here I have, uh, let's see, the x component will be 2 minus minus 2 over 3. That's, again, once more, is going to give me 8 over 3. And the vertical component is minus 4 minus 0, and that's minus 4. So let's see, let's call this vector here the vector on L2. So I'll say L2 vector, and this will be a vector on L1. I'll call that. L1 vector has components 8 over 3 and 4, while L2 vector has components 8 over 3 and minus 4. Now using this I can find the magnitudes of L1 and L2. So magnitude of L1 is 8 over 3 squared plus 4 square root, and that gives me, let's pull out the calculator, 8 divided by 3 equals squared plus 4 squared equals square root. That's let's see, 4.81. Now if I tried to do that also for L2, I would get also 4.81. So L2, its magnitude is also 4.81. Now applying the algebraic approach to scalar product, I do x components multiplied to each other. That's 64 over 9 plus, now the y components multiplied to each other, that's negative 16. And if I pull out the calculator, do 64 divided by 9 minus 16, I get negative 8.8 repeating. So that's negative 8.8 periodic. That is now the scalar product. This gives me the scalar product. It's also equal to the magnitude of L1 times the magnitude of L2 times the cosine of the angle between them. Now L1 and L2 we found to be 4.81, and I'm multiplying it twice to itself with itself, so it's squared cosine theta. Dividing both sides by 4.81 squared, 4.81 squared, this cancels. I'm left with cosine of theta equals, let's pull out the calculator, negative 8.8 divided by 4.81 squared gives me 0.384. Now if I want theta, I have to take the cosine inverse of 0.384, and on the calculator that gives me 67.41 degrees. So this theta, this angle over here, I'll write it in blue, this angle here is 67.41 degrees.